assignment projectile question. The first question was detail B1 fill out. During a football match, the ball is kicked towards the goal at an angle of 15 to the horizontal. From a distance 11 meters as shown. The ball has a diameter of 0.22 meters and initial speed of the ball is 26 meters per second. By means of calculation, determine whether or not the ball will pass into a goal. And we can ignore the effect of air resistance, like because the air resistance can affect the range, so we are ignoring the effect of air resistance. So these projectile questions, when we solve for all of them, we consider that there is no air resistance. So first, what we will do, whenever you're solving a question related to the projectile, the first thing you should always resolve the velocity into components, the horizontal and the vertical components. So we have the launching speed, which is 26. So this is 26. So this will have two components. The one which is with an angle, that is 26 cosine 15, and against the angle will be 26 sine 15. So the horizontal component will be 26 cos 15 degrees, and the vertical component will be equal to 26 sine 15. First, we work out the horizontal and the vertical component. The horizontal component will be like 25.1. What about the vertical component? What's the answer? 26 sine 15.
6.73.
6.73. So these, and to just confirm this, 26 cos 15.
So 25.1.
25.1. So we have both components. Now, as I mentioned, this goal is 15. It's 11 meters from the position where the player kicked this. So we will find how much time it will take to cover this 11 meters. And from that time, we'll find at what position or at what height the ball is there when it cover 11 meters. So first we'll calculate the time to cover 11 meters. 11 is the horizontal distance, so we'll use the horizontal component. We will have a formula: speed is equals to distance divided by time. So time is equals to distance divided by speed. The distance is 11 and the speed, we'll take a horizontal component, which is 25.1. So 11 divided by 25.1.
0.44.
0.4. So means 0.44 seconds it will take to cover this 11 meters. Now we will find if it takes 0.44 seconds, at what height this ball is there, like position above the ground. So for whenever we are finding the position, like the height, we use the vertical component. So we have the formula, like we have the equation of motion, we have to use either 2as equal v square minus u square. So we have the time, we have the initial velocity, we can use s is equals to ut plus half at square. So use the initial velocity, which is 6.73, because we always substitute the vertical component. Time is 0.44 plus half, and because it is moving against the gravity, so 9.81, and time square 0.44 square. So when we simplify, we'll get the distance, the vertical height, which is 2.01 meter. So this ball will be at the height of 2.01, and plus, as they mentioned, the diameter of the ball like 0.22. So maybe like the ball is 0.22 meter up or 0.22 meter down, because this is a position they've mentioned. So what will be the total vertical height, like total vertical? So it will be point, you can just simply add the size of the ball, which is 0.22. So we have the vertical height plus the size of the ball, which is 0.22 diameter is there. So the total maximum height for the ball or the position of the ball can be 2.23 meter. So if it is 2.23 meter and the goal, this is 2.23 meter. The ball is at 2.23 meter, but the goal is 2.4 meter. So means what is like we by mean of calculation determine whether or not the ball will pass into the goal. So what will happen? This ball will pass into the goal. Is it clear?
Yes, sir. But
So
why we are taking 11 meter as the horizontal distance?
why we are taking 11 as a horizontal distance? Because they mention in the question here that during the football match, the ball is kicked toward the goal at an angle of 15 from the distance of 11 meter. Like a ball is kicked from a distance of 11 meter. The distance between the goal and the football, the horizontal distance is 11 meter. That's given in the question.
Okay, sir, clear.
Then next question is 21A. 21. So 21A3 was there, but I will just discuss all of them. In area where in areas of the world where the planes are unable to land freely, land free fall airdrops can be used. Look, when aircraft is moving the same speed, when it drop the package will also move, because first the package is with the aircraft or inside the aircraft, so the speed at which the package is moving will be same as the speed at which the aircraft moves initially when it is dropped. So initially, when we drop, both will have the same horizontal speed. So if there's a horizontal speed, it means it will move or it will travel horizontally. So what will be the trajectory or the path it will follow? So the path followed by the, because the gravity is also acting on the package, so this will be the path it will follow. So that the time for the supply to reach the ground is about 4 seconds. So we have the height is there from which the package is released, and the plane is traveling at a speed of 75. So if plane is traveling, the package initially also 75 meter per second. And this vertical height is 63. Look, whenever object is dropped from certain height, the vertical component of a velocity is 0. It starts to increase, but initially it is 0. So we can use the equation of the motion that S is equals to ut plus half at square. Initial vertical is 0. The gravity is 9.81. Why we are taking a positive value? Because it is moving same as the direction of a gravity, that is downward, so it is positive. So when we simplify, it will be 63 multiplied by 2 divided by 9.81 in a root. Because when we simplify this factor will be 0. So when we simplify this, will give us the time it takes to reach the ground, which is about 3.6 second. The 3.6, which is about 4. It's like not exact 4, it is about 4. Then the next part, calculate the horizontal distance. So we already have the time. The time which we calculate in the previous part, 3.6. And we have the horizontal speed that was 75 meter per second. So if we know the horizontal speed, we know the time it takes to hit. We can, for a horizontal, it is always speed is distance divided by time. So distance is speed multiplied by time. So speed is 75 and the time is 3.6. For example, if in exam you solve this question and you're not able to get the answer for this one, so then you can use this 4 seconds here. Because that's the reason why they give this number. So you can use this 4 seconds and get the final answer. So it will be about 270 meters. Is it clear?
Yes, sir.
Then next question is 29B. Calculate the initial velocity of a golf ball. So the golfer hits the ball and it lands at a distance of 250 meters from the golfer. So means the range is given to us. They provide us the range. And the golf ball is given initial velocity u. So we launch with initial velocity u at an angle of 40. So if I draw a figure for this, like the initial velocity is u, the angle, launching angle is 40. The range, it covered 250 meters. And we need the initial velocity for this. So we can solve, either we can use equation of the motion, or we can use speed is equals to distance divided by time. And we already show that the time is equals to, like the previous part, that here we showed that time is equals to given by this expression. How time is given by this expression? Like t is equals to 250 divided. It is same thing. Speed is equals to distance divided by time. The time is equals to distance divided by speed. Distance is 250 and the speed, because it's about the horizontal, so it will be horizontal component u cos 40. So that will give us the time. Now we need the initial velocity. So if we need the initial velocity, we can either use equation of the any equation of motion like v equal u plus at. But and in that case, if we are taking v equal u plus at, we'll divide the motion into half. Like we'll take the final velocity 0, initial velocity will be u sine 40, and then we'll substitute the value. Or we can also use s is equals to ut plus half at square. And if we use that s equal ut plus half at square, because when it is launched, it is going up, the vertical displacement is increasing, and then it comes down, so vertical displacement decreases, and eventually the vertical displacement is 0 because it land on the same position. So if I use this equation to solve this part, if I use s equal ut plus half at square, now when we solve for this, s, the vertical displacement, so whenever like a complete projectile motion is there, object is launched, reach certain height, and then come back to the same position, the vertical displacement is 0. The vertical displacement is 0. What about initial velocity? Because that is the vertical component, so it will be u sine 40 multiplied by time. What about the time? Here you can see we work out the expression for the time, which is 250 u cos 40 plus half. Acceleration is due to gravity, so 9.81 as the acceleration, and for one complete motion is there, so acceleration due to gravity 9.81. And now again the time square is there, so it will be 250 square divided by, and it is moving against the gravity, that's why it will be negative. And this will be 250 square u cos 40 square. Now we simplify like mathematical rules. This u will cancel with u. Sine 40 divided by cos 40. It will be tangent 40. So it will be 1040 into 250 minus 9.81 divided by 4, divided by 2.
Yeah, it's minus 4.905.
So 4.90.
Yeah.
And this 250 square is there, 250 square divided by u square cos 40 square, or cos square 40. And this whole factor is 0. So we'll move this other side. Just a minute, I'll use the space. Like I will utilize the whole space. So we use this equation, S is equals to ut plus half a t square, because we consider the whole projectile motion. So vertical displacement is 0. So if the vertical displacement 0, what about the initial velocity u? That is equals to u sine 40. What about the time, which it's already we have shown, that is 250 divided by u cos 50, u cos 40. So equal to 250 divided by u cosine 40 plus half. Acceleration is due to gravity minus 9.81, and this will be 250 divided by u cos 40 whole square. Now the whole equation is in terms of u, so we just simplify. U will cancel with u here. Sine 40 multiplied by 250. What's the answer? So it will save the space. Sine 40 multiplied by 250.
The 160.6.
And that is divided by cos 40. The answer?
The 209.
209. Okay, this is 209. And this was 250 square. 250 square.
Yeah, 250 square. The 62,500.
Multiplied by 9.8.
Yeah.
Then divided by
613,000.
divided by
Okay.
2.
Yeah. 306,560.
And then divided by cos 40 square.
40 square. Okay. 522,409.
How much? 5?
1 minute, let me write.
Okay, we'll solve by step. 9.81 divided by 2.
4.9.
Multiplied by 250 square.
Multiply by
250 square.
250 square. Yeah. 306,562.5.
300 and
6,000.
in digits. 30.
306 562.5.
0.5.
Yeah.
Divided by u square cos 40 square. Now this will move other side because it is negative, it will move other side. So it will be P06562.5 divided by u square cos 40 square equal to 209. Now this is divided, other side will be multiplied. So cos 40, right, cos 40,
Yes.
then square that answer
Okay.
multiplied by 209.
Yeah. 122.
122. 122 u square. Now this whole number
Okay.
divided by 122 and take a root.
306 by 62.5.
Divide by
122.
122.
It's having 50.12.
So 50.1 meter per second. So that is the initial speed. Is it clear?
Yes, sir.
So the expression why we took the vertical displacement 0. So it is always the case whenever object land on the same surface, the vertical displacement is 0.
Okay.
Then we have question 30A and B. So the firework is launched into air and it explodes once it reaches the maximum height. The fireworks are designed to explode at a maximum height of 350. The vertical component of the velocity at a launch is about, so we have to show that it is, so maximum, if we know the maximum height, we have the formula 2as equal b square minus u square. So 2 expression is due to gravity minus 9.81. The vertical height is 350 and the final velocity is 0 because at maximum height the final velocity is 0 and then u square. So when we simplify, it will be minus 2 into 9.81 into 350 equal to minus u square. Minus will cancel with minus and just take under root, you will get the value for initial velocity. Then the second part, the maxima, the vertical component of the velocity at a launch depends on both the initial velocity of a firework and the angle between. Sketch a graph showing the initial velocity required for a firework to reach the maximum height, how it varies with the angle. Look, we have to show it is about the initial velocity or initial launching speed is about 80. So example, what could be the maximum and the minimum values? So the word, we have the vertical component, like vertical component will be equal to u, the initial velocity, sine theta, and that answer should be about 80 because as I mentioned here, the vertical component of the velocity is about 80. Our answer might be 82, 81, but according to question, it should be 80 or about 80. So it means the product of u sine theta should be about 80. Now, when the value of, because we have the angles, we have 90. So what is the value of sine 90? Sine 90 is equals to
1.
1. So sine 90 is equals to 1. What will be the value of u? The value of u will be 80. Like if angle is 90, or if we launch the projectile at an angle of 90, the initial velocity value should be 80. So it cannot be 0. It will be the initial velocity value will be 80. You can mark this axis like say 50, 100, 150, and 180, or 200, sorry, and 250. So when the angle is 90, the value of the initial velocity should be 80. So it will be somewhat here. If the value of the angle is 45, so what is the value of u, the initial velocity? 80 divided by sine 45. What's the answer?
It's 113.
113.
113. Yes.
So 113. So somewhat it will be here, somewhat according to. When it is 45, it will be somewhat here. Same thing. If I take the initial velocity, the angle, launching angle at 30. So what is the initial velocity? It will be 80 divided by sine 30. So basically, the
160.
160. So it will be somewhat here. So if you can see, the product of the two quantities should be constant. When the product of two quantities is constant, it means they are inverse or inversely. And when two quantities are inversely proportional, what will be the shape of the graph? It will be a curve. Because the value of u sine theta should always be 80. So it means the product of two quantities should be constant. If product of two quantities is constant, we say two quantities are inversely proportional. And what is the shape of a graph? When two quantities are inversely proportional, so it will always be a curve. Is it clear? But it does not reach the x-axis, y-axis. It is a curve.
Okay. But why we are taking 80 as a constant?
Because they mention initial velocity is about 80. Like initial
Okay. Means I
vertical.
can take like that.
Yes.
But I have to take this one. But I have to take the rounded value or exact one.
No, you can take your value as well. Like example, you solve this question and you got the answer 82. So you can take initial, the product of u sine theta should be 82. Because I did not solve this part, that's why I was taking 80. But if you solve the part A1, then you will take that as 82.
Okay, sir. Yes, sir, it's clear.
Okay. Then question 33. A student wanted to estimate the maximum diameter of a firework after exploding. The student estimated the time between seeing the firework and explode and hearing the firework explode, and the angle phi is there from top to bottom. So basically, if student need a diameter, like the idea is that we can describe, the question is describe how student could determine the maximum diameter of exploded firework. So what we can do, or what student can do, if student can determine this distance and phi is known, so if we take half of the phi, we can consider this as a right angle triangle, because this will be the hypotenuse, perpendicular, and base. So this angle will be phi by 2. And if we are able to determine like the distance, because we know the time and we know the speed of the sound, so Using the speed of the sound, speed is equals to distance divided by time. So speed multiplied by time is equals to distance. So speed of the sound is known, time is there, so we can find the distance between the firework and the person, student. So we'll have this distance. And we already know the phi. So if we know the phi, so we can, half of this angle will be phi by 2. So if I find this perpendicular, how I have the base, I have the angle, I need perpendicular. So what I can do, I can use tangent theta or tangent phi by 2, because we are not taking full angle, we are taking half angle. So tangent phi by 2 will be equal to perpendicular. So this is unknown x divided by base. So base is diameter. Sorry, base is a distance, not diameter. Distance from the firework to the person. So distance multiplied by tangent phi will be equal to x. So we'll get the x. But what, to get the full diameter, it will be 2x. So what we'll do, we'll multiply to get the full diameter. It will be equal to 2x. So it will be equal to 2d tangent phi by 2. So first, determine the distance. How to determine the distance? Because speed of a sound and time we already know. So using the speed of a sound and time, we'll find the distance between the firework and the person. And we use the component because the full angle is phi by 2. So we took half of the angle. Full angle is phi. So we took half of the angle. That's why it is phi by 2. So using phi by 2 and the distance, we work out radius, and twice diameter is twice of radius, so it will be 2r or 2x is equals to the diameter. Is it clear?
Yes, sir.
Any other questions from this? These are the questions which you have sent as a doubt.
But I want one projective motion with the diagram of that.
Which
Question
one?
number
Page, you can tell the
1
page.
minute. That is fine. Page number 36. 36B. 26.
Sketch a path of a water droplet on the diagram above. So you have to draw a path like this.
Okay, sir.
So this was the assignment related to the doubts related to assignment projectile.